When you think of preventative healthcare, what comes to mind? It's probable that you just thought of annual physical exams, immunizations, or disease screenings, among others. While most of us are familiar with these common checkups as a means for preventative care, did you know that retinal exams are another procedure critical for early disease detection? Whether you have or haven't been to an eye doctor, you may not know what a retinal exam is. Essentially, retinal imaging takes scans of the back of your eye that an ophthalmologist can use to detect signs for cancer, diabetes, heart diseases, and macular degeneration, among many others. The problem is, a lot of people don't make annual eye exam visits, and even if they do, not a lot of insurances cover the costs. Out of pocket in the United States, these exams cost an average of $200. And if you want to do the test at home, current devices in the market are expensive or not self-administered. Overall, this lack of accessibility to early disease detection is a pressing issue our sponsor, Pursuant Health, is trying to address. Pursuant Health's current kiosks provide free health screenings to 4,618 retailers nationwide in stores like CVS and Walmart. They want to add retinal imaging to their kiosks so that the public can have access to a quick, easy, cheap, and self-administered retinal exam. This is where our team comes into the picture. Hello, we are Team Theia, named after the Greek goddess of sight, and we have come together with Pursuant Health to address the following objectives, which we have broken down into 5 goals. We are trying to design a proof of concept device that can locate, adjust, and align properly to the eye, and perform within a short time frame. The device must accommodate a variety of user circumstances, such as height, eye color, pupil size, and mobility constraints. It must also be cost-effective to produce and scalable for easy integration into thousands of existing kiosks. Let's start with the first goal, which leads us to presenting our final design. With the use of 3 stepper motors, a Raspberry Pi as the processor and camera, and Arduino used for motor controls, and Python for image processing, our device can locate, adjust, and align accurately and consistently to the pupil. Here's a video demonstrating this. First, once the program is run in Python, the user puts their eye to the face rest. The axes then calibrate by moving to the origin position. Next, the camera moves to the center of the frame to get into viewing position of the eye. In a rapidly iterative process, the camera finds the eye, the algorithm recognizes it, and then sends precise coordinates to the Arduino to move the motors and finally align the camera to the pupil. Once the eye is stable, the algorithm moves the camera upward so that the objective lens is now in view of the eye and the image behind the lens is focused and visible. As you can see, the first goal was met. Next, on to the second goal. From start to finish, it takes around 30 to 45 seconds for the whole process to run, which met our original design intent of performing under 1 minute. The third goal was addressed after running many successful tests on various eye colors, heights, and pupil sizes. For the fourth goal, the final cost of our device was around $450, which compared to current devices on the market is significantly less expensive. Finally, to meet our last objective, we designed our entire device to fit comfortably in the back of current kiosks so that very little retrofitting is required. For future works, after successfully building the capability to align with the pupil, the next thing to do is integrating picture-taking capabilities to take the retinal scan. Overall, our team had a lot of fun this semester taking Capstone, and we are very proud to present our design at Expo. Special thanks to Dr. Jerry Walla, Dr. Harris, and Leslie Summers and David Rosenblatt of Pursuant Health. Please come by our table and test out our device, and please make an appointment to get a retinal eye exam.